So back with another video on this part here. Now I've set it up with the scriber and I finally got it sorted, so bear with me with this. So what I found, or what I was told, that in Marlin, when you open Marlin up and you go into the configuration file, and then you head way down to, it's a bit sad I know this off by heart, where this is, there's default axis step per unit. So this is your X, Y, Z and your E for your extruder, but we're not using that. So it's these 80, 89.5 and 1692.18. So the settings underneath it, which was, I don't know whether you can see that there because it's not highlighted, but 100, 214.9, 2256.21, and then the 760 times 1.1, which is the E. So those numbers there, the 100 I've reduced to 80, the 214 down to 89.5, the 2556 down to 1692.18. And basically what I was doing wrong, or what I found was wrong, was when I would set this for 100 millimeters travel, it was going way further. So when it was looking at cutting out part, it was not accurate. So I took all the dimensions and the teeth of the, or the number of teeth of all the pulleys, and I basically went through and worked out how far it travels for a full revolution. This guy down here was the best one because it's got a big pulley and a small pulley, so to work out, calculate the ratio of those two, and then that one back to that one to work out what that one was, if that makes sense. Anyway, bit of trial and error, and I've come up with these numbers here. Now what I found, that if you want to edit those, the best way to do that is to go to your configuration H file there, and we'll do that, and we edit that with Notepad++. If you come down to line 482, there's the numbers there, and of course you just modify them as you go. So if we wanted to change that, we could do whatever we want, and then you'd hit the save button and away you go. Now I'm not going to save that, of course, because I just changed that. So basically that would have changed that number in there. So that's in Marlin. Then of course all you do is you make sure, what I do, a quick old hand at Arduino, is to go examples and then go down to EEPROM, clear the EEPROM. You get this here. We're already connected to the Mega 2560 board through COM port 4. Hit the upload, it clears the chip on the board, and then of course you just press upload and away you go. So if we have a look at that now, and we go into our Pronterface, what we can see is that we've got everything we move now for 100 millimeters moves 100 millimeters. So that was the big test, and it got quite tedious. So if we load the file there, new bracket, and we go to print, now what I've done, there's the bracket there, and I've just put a scriber there so you can actually see whether it's accurate or not. We'll press the print button and we'll have a look. Now you've got to remember, it's going to have room for the cutting tool. So that's basically it. So that comes back up and it'll rehome itself. So that's in Pronterface. So if we disconnect that and we shut it down and we go to our CNC G code controller, so we're now connected with this guy. We go to CNC milling and there's our shape there because we've loaded that file previously. Okay, so it comes up with a couple of warnings, but they're obviously not an issue. So if we go milling, you can see it'll go through the G code, and what will happen here, I'll run it twice so you can see it. It starts showing you the track in red. Now don't forget that this is flipped over, so it's drilling through, so it's kind of like a mirror image, if that makes sense. So there's the G code running there. And basically that's it. So if we go back and we run that again, and we do that, you'll see we'll run exactly the same. So it'll come in and it'll run through. So the two things that I was getting wrong today was one was that Marlin problem that I showed you, and the other one was where this was relative to the graph. Now if you have a look where that is now, it's actually in the bottom corner, and that was to do with my X, Y and Z axis, the way it was facing when I went into Fusion 360 and set it up, and I'll take you there and show you what I mean by that. Okay, so what I did is go into my file and pull the arm out. There's the arm I've designed up. Go into Cam, Setting, New Setup, and of course the milling operations we're using and the orientation. Now you can see Z is supposed to be up, so there's two issues here. One, it's facing the wrong way, and secondly, it's in the wrong spot. So if you click on that and click on the face, you get it the right way, but now it's in the center point of the model. So we want to actually put it out to the side. So I need to pick this corner down over here, so that's the bottom left hand corner, if that makes sense. So if you imagine that's the graph that I just showed you, that's the bottom, so that's Z. It has to be up, X and Y. So it's now going to come up into the grid in the CAM project. So we now go to stock, everything's there with all set up, so it's 96 millimeters long, 21.7 wide, 3 millimeters thick. So once we've done all that, we go into 2D contouring, and all I did was, for the tool I selected was, the tool I selected is 1/16 flat end mill. So pick that, and you can see that coming up there. I don't need the flooding on. I'm not water cooling this. Now down in here, the speed that I want is around about 500 millimeters a second, 500 millimeters a minute. Same in there. And our plunge rate, which is the rate that it goes into the material, is going to be 50. and we go into the geometry, so we can go and now select what faces we want to cut. So I've selected the bottom face, and you can see the direction of the arrow there is going to cut round this way. I can double click on that and send it the other way if I want. But we've got all our heights in here, so everything's right with our height, our clearance height, our retraction height after we're cutting. Our feed and our top is at 0. And then we can look at our passes there. If you've got multiple passes, you can set it all up. And anyway, that's where we're at. So it'll now calculate all that for me. And if I move that around, and I can just show you a bit better view of the machining there, you can go up into this little guy, which is the simulator, and you can simulate what it looks like. So we'll have a look at that view, and then we'll have a look at a little bit different view. So we'll just check that out again from a sort of a different, slightly different angle. So that's going to cut all the way through there. And that's what we were doing. And then of course you close all that, and then you go to actions. What posting the process means now is that you actually send it out to your machine, and all machines are different. I had to get this file here downloaded from one of the guys off the Facebook support page, so that was wrong. So G code, and it tells you where I'm going to put my output, my file. In here you can check all your tolerances, and of course you can post that. Now what that does for you, it'll tell you that there's a test, so we'll say yep. And what that does now, it brings up another mirror of your G code. So you can have a look in here, and this tells you what's going on with your G code. So pretty straightforward. So as I said, what I was doing wrong with that, I had this set up in the wrong, not only the wrong place, but the wrong plane. So 2 issues sorted today. This guy here, and of course the speed, or the relative distance of how far the machine travels to calibrate it. So anyway, that's about where we are with some of our parts. And I've been playing with this for probably 10 hours. This CAD program, CAD-CAM, it's really good. I like this. It's very, very easy to understand and use.